A reality that we have come to accept is that relative to us, almost everything in the universe is incomprehensibly distant. Presuming we're not alone, even if interstellar communication could be established, it would still take years, decades, centuries, or more for information to be transceived. The universe may be crowded with isolated specks of life, all willing yet unable to overcome the socially impeding physical laws of the universe. But not every region of the universe is equally dispersed. A good example of this are globular clusters, abnormally dense spherical regions of stars. Each cluster can contain many hundreds of thousands of stars, and the Milky Way is currently orbited by more than 100 such clusters. While the closest star to the Sun is over 4 light-years away, a typical distance between stars in a globular cluster is only 1 light-year. Near the center, stars may only be separated by a few astronomical units, which is the distance between the Earth and the Sun. Intelligent beings inhabiting a planet orbiting a star inside a globular cluster may find interspecies and interstellar communication to be the norm. The night sky would be illuminated by thousands of nearby stars. This is also one of the reasons why in 1974 a radio message encoded with information about humanity and Earth was beamed towards the globular cluster known as Messier 13. But given that M13 is 25,000 light-years distant, we have to wait another 50,000 years until we don't receive a reply. However, some argue that the close proximity of the stars may inhibit stable planetary orbits, thus rendering the development of life improbable. As of the making of this video, only one exoplanet has been detected inside a globular cluster. Much like all other celestial orbs of stuff, stars are classified according to various classification systems. The current system is known as the Morgan-Keenan classification and categorizes stars based on their temperature and luminosity. A famous representation of this system is the Hertzsprung-Russell diagram. It charts the properties of some 23,000 stars with luminosity on the vertical axis and temperature on the horizontal. The Sun would land here, making it a fairly average G-type main sequence star. At the very top we find hypergiants, and by volume they are the largest stars in the universe. At the bottom we find white dwarf stars, incredibly dense but voluminously small. In some 5 billion years, the Sun will first expand into a red giant before condensing back into a white dwarf. But what happens next? Are these Caucasian Tolkien creations doomed to roam the galaxy for all eternity? Well, not for eternity, but almost. Once the Sun has evolved into a white dwarf, it will begin to cool down. This cooling process will continue for more than a quadrillion years. To put that in perspective, I can't put that number in perspective. Though some stars may actually dim the lights in just a few trillion years, so stay tuned for that. After an indeterminate and incomprehensible amount of time, the Sun will eventually devolve into a black dwarf. A star that emits no light nor heat, just a dense and dark gravitational mass, perhaps still orbited by equally dark and lifeless planets. But as the universe is only 13.8 billion years young, black dwarfs are purely theoretical and do not yet exist. But even if they did, they would be extremely difficult to detect. When talking about the severely deficient budget of NASA, it is often compared to the vastly superior budget of the US military. US military spending frequently exceeds 50% of the total discretionary spending of the federal government, while NASA has been hovering around 1.5% for the past couple of years. If you're a space enthusiast and you ever find yourself in a situation where you need to fake some tears, just picture this graph. Works every time. I don't know if the US military needs $600 billion every year. Perhaps they do. Perhaps that money is put to good use and every dollar is essential. However, I do know that if they wanted to, they could build 2 Hubble telescopes just for fun. Because they did. In June of 2012, NASA announced that they had been given 2 space telescopes by the US intelligence agency known as the National Reconnaissance Office. The NRO primarily builds and operates spy satellites for the US government, and while the 2 optical telescopes were built with the intention of observing the Earth, they could easily be repurposed for astronomical observations. These 2 pristine telescopes have been collecting dust since the millennium shift and are in the same class as the Hubble Space Telescope. But even though NASA avoids the cost of building 2 Hubble-equivalent telescopes, they still have to pay for various instruments and electronics, as well as the launch of the rockets, so it will get quite expensive regardless. And with such a minuscule budget, this means that the telescopes will continue to collect dust for quite some time. If everything goes according to plan, one of the telescopes may be launched into orbit by 2024. But given that this is NASA we're talking about, a good rule of thumb is to only trust their estimations when it's about celestial mechanics. In the Star Trek universe, there's a planet called Vulcan, which, logically, is the home of Vulcans. However, prior to the conceptualization of this fictional alien species and their homeworld, there was a very real astronomical search for a hypothetical planet called Vulcan. In previous episodes, I've talked about the French astronomer Urbain Le Verrier and his discovery of the planet Neptune. Well, after his discovery of Neptune in 1846, Le Verrier decided to tackle the puzzling discrepancy between the observed and theoretical motion of the innermost planet, Mercury. After studying the planet for over a decade, he published a paper in which he hypothesized that Mercury's anomalous orbit was caused by one or multiple undetected celestial bodies between the Sun and Mercury. Then, in late 1859, an amateur astronomer claimed to have observed the transit of this hypothetical planet. Le Verrier was now convinced of the planet's existence and subsequently announced its discovery in early 1860. As news of the sighting spread across the globe, this sun-grazing planet was aptly named Vulcan because in Roman mythology, Vulcan is the god of fire. While many doubted the existence of Vulcan, Le Verrier's previous discovery of Neptune lent credence to his claim, and sporadic sightings of intramercurial planets would continue throughout the 1800s. But as no one could seem to provide any concrete evidence of Vulcan's existence, more and more began to question the validity of these sightings. Then, in 1915, Albert Einstein published The Theory of Relativity, which perfectly explained the motions of Mercury and consequently eliminated the possibility of an intramercurial planet. The supposed sightings had likely been confused with comets, sunspots, Vulcan starships, or other celestial phenomena. As for Le Verrier, he died in 1877, still convinced of having discovered a planet named Vulcan. If you've ever seen the launch of a space shuttle, you'll know that an iconic component of the launch vehicle was the enormous rust-colored fuel tank. But the external fuel tanks attached to the 2 initial shuttle flights, known as STS-1 and STS-2, featured a more consistent white coating. It would be easy to assume that this was a mere aesthetic decision, but it was actually intended to protect the tanks against ultraviolet light. Once this white privilege was deemed unnecessary, future tanks were simply left unpainted. This also had the added benefit of shaving off some 270 kilos. That's 270 kilograms of paint. Sure, the tanks may have weighed 35 tons, but given that each mission cost about $450 million US, or some $18,000 per kilogram, they saved nearly $5 million by not whitewashing those fuel tanks. Well, I guess they did whitewash the tanks given that they washed off the white paint. So they whitewashed the tanks by needlessly making them white, only to whitewash the tanks by reverting back to their non-white state. Or perhaps I should just avoid anthropomorphizing the painting practices of fuel tanks. In 1981, the Soviet Union launched a probe named Venera 14. The probe was headed for Venus, and its mission was to land at the Venusian surface to take some photographs and to gather data. In 1982, it made a successful descent, and this is one of the photos it managed to relay back to Earth before it succumbed to the extreme Venusian climate. Before any photographs could be taken, however, the system would automatically eject the lens cap protecting the lens of the camera. An ejected lens cap can be seen resting on the ground in this photo taken by a preceding identical probe named Venera 13. But in the Venera 14 photo, the ejected lens cap landed here, the precise location at which this spring-loaded metal arm was intended to strike the ground to measure the compressibility of the soil. Instead, Soviet scientists back on Earth received the data on the compressibility of the lens cap. If disaster strikes and astronauts and cosmonauts aboard the International Space Station should be forced to make an emergency evacuation, they would have to board one of the two Russian-made Soyuz capsules, each with a capacity of 3, and descend back to Earth. All crew members are trained for these circumstances, so it shouldn't be much of an issue, but one problem with returning home after an extended stay on the ISS is that the human body requires time to readjust to Earth's gravity. If the capsule should happen to land in a difficult-to-reach location, the crew will have no choice but to wait until further assistance arrives or till their bodies will allow them to seek help by their own accord. First of all, the crew will likely find it difficult to stand and walk for at least a couple of days. This is astronaut Scott Kelly after spending a year in space and returning to Earth in March of 2016.
Like Jar Jar Binks.
Crew members may also lapse in and out of consciousness for short periods of time, as the circulatory system would struggle to provide an even flow of oxygen-rich blood to the brain. A day after returning home in 2006, astronaut Heidi Marie Stephanician Piper collapsed twice while addressing a crowd for this exact reason. As a direct result of this incident, astronauts attending conferences shortly after returning from space are now required to sit. Now, if you should ever find yourself in the vicinity of an emergency landed Soyuz capsule, as one does, you'll actually find instructions printed on the side of the craft on how to open the hatch and assist the crew inside. In 1959, before any human had yet to venture out into space, officials at NASA discussed whether to label such individuals as astronauts or cosmonauts. Both terms are derivatives of ancient Greek, and the suffix "naut" initially meant sailor. The prefix astro means star, while cosmo means universe. So astronaut translates into star sailor, while cosmonaut translates into universe sailor. Even though cosmonaut would be a more accurate description of this profession, astronaut emerged as the term most favored by Americans. But once the Soviet Space Agency sent the first human into space, they chose to use a term that translates into cosmonaut, and due to the competitive nature of the space race, neither country was prepared to adopt the terminology used by the other. So instead of Soviet astronaut or American cosmonaut, the Soviet term was anglicized while the American term was cyrillicized. Another reason is that both astronaut and cosmonaut are titles of a profession and not direct synonyms for any person who ventures out into space. Thus, the agency responsible for sending people into space is also responsible for titling that profession. And while other such titles do exist, such as spationaut for French, taikonaut for Chinese, and viewmanaut for Indians, astronaut is by far the most common, except when in reference to Russian cosmonauts. In the early 1960s, the US military launched some 480 million tiny copper needles into orbit. This was done in the belief that this orbital ring of needles could serve as an artificial ionosphere, facilitating military communications by reflecting radio signals back to Earth. This would allow for global communications without the need for undersea cables. The project was initially deemed a success, but as the needles dispersed over time, the signal strength gradually diminished. The project was eventually scrapped in favor of communication satellites, so this swarm of needles was simply abandoned under the presumption that they would burn up on re-entry within a few years. But not only does a significant percentage of the needles remain in orbit some 5 decades later, they have now coalesced into clumps of metal due to contact welding. 39 of these clumps are currently being tracked, but more are believed to exist. The 8 planets of the solar system are currently orbited by 175 moons, but how many moons does the Earth have? 1. The Earth has 1 moon. It's this one, you may have seen it. But since 2010, you could say that Earth has 2 companions in the form of the Moon and something known as a Trojan. In 2010, a 300-meter-wide asteroid known as 2010 TK7 was found to orbit in close proximity to the Earth around a region in space known as a Lagrangian point. A Lagrangian point is 1 out of 5 points in a 2-body system, wherein the forces exerted by the 2 celestial masses, in this case the Sun and the Earth, create a sort of gravitational and centripetal equilibrium. This is what the strange orbit of 2010 TK7 looks like as it guides the Earth around the Sun. The easiest way to imagine this is that the asteroid orbits an invisible point in space known as L4 while simultaneously orbiting the Sun. Although astronomers insist upon this being the first and as of yet only Earth Trojan, Windows users around the globe beg to differ. While our weak excuse of a planet has only managed to attract a single Trojan, the god of the solar system, Jupiter, has likely attracted millions. In fact, the classification Trojan stems from the fact that the asteroids around the L5 and L4 points of Jupiter are named after characters from the Trojan War of Greek mythology. It's been hypothesized that when Earth was still just an infant, a large planet named Theia found itself in an orbit around the L5 and L4 point, much like 2010 TK7. However, due to Theia being as large as Mars, its orbit quickly destabilized and the planet eventually impacted the Earth, which may have resulted in the formation of the Moon.